In this module, we will give you an overview of Lean and Six Sigma. First, we will define Six Sigma, including its history and its basic premises and concepts. Next, we will define Lean. Six Sigma concentrates on the reduction of defects and variation in processes. By defining and measuring customer requirements, you can determine how well your company's processes are meeting these requirements. You can also quantify this using several quality measures, including Sigma level. The probability of creating a defect can be estimated and translated into a Sigma level. Six Sigma, in statistical terms, translates to 3.4 defects per million opportunities. This is considered a world-class level of quality. The project implementation or problem-solving approach is called DMAIC: define, measure, analyze, improve, and control. It is a systematic methodology for improving processes. Most of the quality improvement tools associated with Six Sigma are tools that existed in the TQM methodology, predating Six Sigma. These improvement tools include statistical methods such as hypothesis testing, as well as qualitative tools such as cause and effect or fishbone diagrams and brainstorming techniques. One very important element of Six Sigma is the concept of X's and Y's. If you ever took algebra, you might recall the basic formula Y as a function of X, or Y is a f of X. In Six Sigma, we use this concept as follows. The Y is a dependent variable. It is the variable that we cannot control directly. For example, a Y might be a defect rate for a particular process. The X's are the independent variables. These are the variables that we can change and that affect the Y or dependent variable. In a Six Sigma project, it is our job to identify the vital few X's that affect the dependent variable. We then optimize the X's to control our dependent variables. Finally, we monitor the X's and Y's in the long term to ensure that we sustain our improvements. Let's briefly examine the history of Six Sigma. In 1984, Bob Galvin of Motorola identified the objectives of Six Sigma. 10 times the levels of improvement in service and quality by 1989, 100 times improvement by 1991, and Six Sigma capability by 1992. Bill Smith, engineer from Motorola, is the person credited as the father of Six Sigma. Around 1985, Texas Instruments and ABB began to work with Motorola to develop Six Sigma further. By 1994, a significant number of experts left Motorola and Six Sigma began to spread. Most notably, in 1995, Allied Signal began a Six Sigma initiative as directed by CEO Larry Bossidy. Also in 1995, General Electric, led by Jack Welch, began the most widespread undertaking of Six Sigma. Since then, Six Sigma has spread to multiple industries worldwide, from manufacturing to banking and insurance. There are 6 key ingredients of Six Sigma. Let's take a look at each one of these. First, genuine focus on the customer. Performance measurement begins and ends with the voice of the customer. We need to understand what the customer requirements are. Defects are defined as failures to meet customer requirements. An improvement is measured by impact on customer satisfaction or value added to the customer. Next, data and fact-driven management. Six Sigma requires that we measure and understand how we are doing relative to the customer requirements. We then determine what data we need to collect to dig deeper into understanding the gap between our current performance and what the customer requires. Third, process focus, management, and improvement. We focus on the process as key to meeting customer requirements. In other words, we work on mastering and improving processes to build competitive advantage. Next is proactive management. Six Sigma requires that we set and track ambitious goals. Management must establish clear priorities and must provide active support in meeting goals, and they must challenge the way things are done instead of blindly defending the old ways. They must also reward those who prevent fires at least as much as those who put them out. In most companies, this would be a major paradigm shift. Fifth is boundaryless collaboration. Six Sigma requires collaboration across departments and functions. Management must smash the barriers that block the flow of ideas and action up and down across the organization. Instead of operating in silos within a company, each department must work together toward common goals. Lastly, we have drive for perfection. Six Sigma companies are focused on driving toward perfection, though it is unattainable. Continuous improvement has to be the mindset. With that in mind, spending time on data collection is important. However, trying to be absolutely perfect before taking action is not acceptable. The project management approach or problem-solving approach of Six Sigma is called DMAIC, which stands for Define, Measure, Analyze, Improve, and Control. It is this methodology that distinguishes Six Sigma from other quality improvement initiatives. This methodology begins with defining the problem, the customer requirements, and the opportunity. Next, we measure the extent of the problem and quantify its potential causes. This is sometimes referred to as identifying and measuring the X's, which are those variables that affect our output variable Y. Next, we perform analysis to determine the critical X's, factors, or root causes. After we determine causes, we develop improvements and implement those improvements to remove the causes and improve our process. We then put in place controls and metrics to ensure that our improvements continue to work. DMAIC is used for new processes and products as part of design for Six Sigma. Define the project goals and customer deliverables. Measure and determine the customer needs and specifications. Then analyze the product and process options to meet the customer needs. Then design the detailed process or product to meet the customer needs. And then finally verify the design performance and ability to meet the customer needs. Let's briefly cover where Lean came from. Taiichi Ono, chief engineer at Toyota, was faced with the following situation just after World War II. Toyota had very little money, a very small market, productivity 1/10 that of Detroit, a production requirement of less than 1/100th of Ford. He was asked to catch up with Detroit in just 3 years, that is, in terms of productivity. While it took longer than that, after studying Ford and also taking advice from quality gurus such as Deming, he created a manufacturing system that focused on reducing cost by eliminating waste. Hence, the Toyota production system was born. The Toyota production system is often depicted as a house because it is a structural system rather than simply a set of tools. Let's take a closer look at this system. We'll begin with the goal. The goal of Lean, or the Toyota Production System, is to create the highest quality products at the lowest cost with the shortest lead time to the customer while creating a safe work environment with high employee morale. These goals are upheld by two pillars. The first pillar is just in time, which means providing the next downstream customer with what they need, when they need it, in the quantity that they need it, and at the point in time in which they need it. We use several tools and principles to achieve just in time. We use continuous flow, moving the product from one value-added step to the next with no delay between steps. We set our production rate equal to takt time, the heartbeat of the customer. We use pull systems to build and provide only what the customer needs when they signal for it. And we use quick changeover to become more flexible at building what the customer needs when they need it. The next pillar is quality at the source. This pillar represents the idea that we never knowingly pass defective product to our next downstream customer. We prevent this from happening by implementing tools like line stop, which empower the operators to stop the line and address a problem when one occurs, visual controls to identify problems and prevent problems, mistake proofing to prevent human error from causing a defect, and-on systems, light and audible systems to alert us of errors, and we employ the concept of the 5 whys, root cause analysis, by continually asking the question why until we get to the root cause of a problem rather than addressing symptoms of problems. At the base of the Toyota Production System, we have operational stability. To create and maintain stable processes, we employ standard work, which ensures that our process is consistent and able to meet the volume requirements of the customer. We employ preventive maintenance or total productive maintenance to ensure that our equipment is reliable. And we implement a 5S system to help us organize and standardize our operations and keep it that way. Finally, we employ the concept of hijunka, or leveling the workload, to ensure a smooth flow of production from beginning to end. The final and most important element of Lean is to create a flexible, capable, and highly motivated workforce to make it all happen. We want to create a culture of problem solving. James Womack and Daniel Jones wrote the book Lean Thinking back in 1996 to further describe Lean. In it, they identified 5 principles of Lean. The first principle of Lean is specify value. Value is what the customer is willing to pay for. We need to understand what the customer needs and values first. The second principle is identify the value stream. We need to identify the value streams for our products or services and then map those value streams to identify waste and sources of waste. Value streams include all of the actions required to deliver our products or services to our customers. Next, we create continuous or one-piece flow. We eliminate delays from our processes. In manufacturing, this means eliminating work-in-progress inventory and moving the product from one step to the next with no delay. We then employ the concept of pull. Every point in our process has a customer, and we create a system that allows us to only make what the next downstream customer needs. Finally, we pursue perfection. We continue to find ways to eliminate waste and improve quality. Let's take another perspective on Lean. Imagine the timeline that begins with the customer placing an order and ends with the customer paying for that order. That timeline includes things like purchasing raw materials, manufacturing, planning, engineering, shipping, customer service, all of the processes necessary to deliver the product or service. That timeline includes value creating time, time in which you are transforming the product in such a way that the customer is willing to pay for it. It also includes non-value creating time, time in which no value is being added. This represents the time in which the product is waiting. Taiji Ono described the Toyota production system this way. All we are doing is looking at the timeline from when the customer gives us an order to the point at which we collect the cash, and we're reducing that timeline by removing non-value added wastes.